Welcome to a new week. This is section 5.6, the half angle identities. These are the last identities that you'll have to be aware of. I was about to say memorize, but that's not necessary for us, right? We can come to the class or come to the test with all of the identities out there. I would highly suggest memorizing the sum and difference identities, as well as all the fundamental identities and Pythagorean identities. It is also good to know these double angle and half angle identities. And so, you'll know in the future whether you're going to have those memorized or not. But just right now, what we want is for you to just have an understanding of them. They're derived in the book, so I'm not going to spend our time deriving them because you can look at that same derivation in the book. What we want to look at is what's called the half angle identities. The most important thing to notice about these identities is that they have a plus or minus outside. That plus or minus, and I'll highlight it here, this plus or minus that we're talking about right here, is not the same plus or minus that is in the quadratic formula. There's not two answers to this. There's only one answer, and you're going to have to choose the correct sign based upon, and that's written right here, choose the correct sign based upon the function under consideration and the quadrant of a over 2, right? The angle divided by 2. So that's what we're going to be dealing with, is something like this. So let's take a look at basically applying all of these guys. So what you're going to have when you sit down to the homework is a problem like number 12 that's here as our first example, example number 1. They'd like us to take the sine of 195 degrees. So what we need to realize is that the sine of 195 degrees is equal to the sine of, and we got to think about, well, what would I have to divide by 2? 390 degrees divided by 2. Okay. So if you took 390 degrees and divided it by 2, you should have 195 there. I was just checking myself since I did that off the top of my head. So what is this? Well, think about where 195 is. We need to use this sine of a over 2 guy that's up here. So I need to use this guy up here. So I point to it since it's right there. So I have to first decide whether it's going to be positive or negative. So I got to think about 195 degrees. 195 degrees, right? Because I need to take into consideration a over 2. I need to take into consideration this angle on the side. 195 degrees is actually in quadrant 3, where sine is negative. So the answer to this is going to be a negative. And so we're going to have to come up with that, and that's awesome because that's good thinking for us. And so we have to put some thought in there. Now we're going to take and just follow that formula to a T. 1 minus the cosine of 390 degrees all over 2. So I do have memorized that it's 1 plus cosine A over 2 and 1 minus cosine A over 2. I know it's plus if it's with the cosine, negative if it's with the sine. So I kind of say, oh, if it's cosine, then it's the positive. If it's sine, and then it's a negative inside that radical. So there's ways to memorize it. So we know about 390 degrees. That's actually in the first quadrant. That has a 30-degree terminal angle. And what's the cosine of 30 degrees? Well, the sine of 30 degrees is 1/2. So this is the square root 3 over 2, all over 2. Okay. So we have the square root of 3 over 2 all over 2. And so you're going to end up with these complex fractions that they think that we can handle. And the big thing is going to be cleaning them up. It would have been really nice if it was just a 1/2. And so let me make sure I'm thinking about that right. Yeah, cosine of 30 degrees is root 3 over 2. And so what are we going to do next? Well, we could clear the complex nature of the fraction by multiplying top and bottom by 2. And so we get 2 minus root 3 all over 4. Well, that's nice because when I split this up, I get the square root of 2 minus 3 all over the square root of 4, which is the square root, 2 minus root 3, sorry. And so let me rewrite that a little bit better. Sorry, I pinched myself into a corner here. Let me just keep working down knowing that I can erase that, and I'll do that a little bit more carefully. So I'm going to split up that square root, 2 minus root 3, all over the square root of 4, and then I'm going to leave the top because I can't distribute a square root, and the bottom is 2. And that's what we have out of that guy, root 2 minus root 3 all over 2. Now I want you to see something that I did wrong. I did a common mistake on purpose just to see if you were to catch it. So, do you see what I did wrong? My final answer, take a look outside of the square root. What's my final answer look like? Is it positive or negative? And we're seeing that it is positive right now. Well, that's no good. I made a determination early on that it should be negative. And so I need to make sure that I translate this negative all along the way. Easy to get dropped, but it's wrong if it's not. It should be a negative angle, and that's exactly what they have typed out there. If you were to type in sine of 195 in your calculator, you're going to get the decimal approximation for that. You give me that on the test and you get no credit. We need you to have experience manipulating numbers like that, working with complex fractions. So if we look, what we did first, and I start to label things because I think it's really important to know. From here to here was arithmetic. Just wondering what angle I would have to have in order to get 195. And it was 390. Now 390 was a good angle because I know all about it because it's 30 degrees beyond 360. Then I used trig. So I used a trig identity. So this is the first time we had to use our class, right? Then I used trig again to simplify the cosine of 390 into a number. And then the rest is algebra, right? Oh, a complex fraction, let's clear it. Oh, square root in the denominator, let's clear it. That's the kicker. Much of what we do is algebra based and arithmetic based. So let's look at this second example, which is problem number 24. I'm going to go ahead and erase this stuff that kind of merged in there with it. And we know that we're going to try to be as careful as we can be. So they would like us to give the cosine of x over 2, given that the cotangent of x is equal to negative 3, and x is in the second quadrant, right? It's between pi over 2 and pi. So what does this mean right here? It means we're in quadrant 2, right? That's what this piece right here really means. Well, that's important for us to know. So here we go. We need to find the cosine of x over 2. Well, we look at our formulas, or we have it memorized, and we know that it is either plus or minus the square root. And I got to replace all those a's with x's if you're looking at it that way. And it is going to be, well, since it's cosine, it's going to be 1 plus the cosine of x all over 2. Right? And we have that above, right? I can flip up there and look at it above. 1 plus the cosine of x all divided by 2. Now this is bad. Do not go forward with a plus or minus. We have enough information to determine whether it's positive or negative. The hardest part is to remember what to focus on. I'll have many people tell me this. They'll say, Jensen, I chose negative. I chose it to be negative. Why did you choose it to be negative? Because they told me it was in quadrant 2. And I say, oh, what's in quadrant 2? Well, x is. Are you taking the, and then I would ask them this, are you taking the cosine of x? No, I'm taking the cosine of x over 2. Read this very carefully. It was said and read, choose the correct sign based on the function under consideration and the quadrant of, not x, not a, but a over 2. X over 2. If you have a second quadrant angle, if you have an angle that's here, and you half it, guess what quadrant you end up in? You end up in 1. Pick any second quadrant angle, like 100 degrees. Let's take half of it. It's 50 degrees. Let's take 179 degrees. Take half of 179. And where do you end up? 89.5, quadrant 1, right? So you're going to get a quadrant 1 angle no matter what. So because of that, the correct choice isn't negative. It is that the thing is positive. So even though it's not necessary, I'm going to put a big blue plus in there, to just highlight that we took that into consideration. So we've used this piece of it to determine that blue check mark. Now the only reason we're not done is because they didn't give me the cosine of x, they gave me the cotangent of x. No problem. Cotangent of x, well, x is a second quadrant angle, right? X over 2 is a first quadrant, but x is a second. And we have the cotangent is negative 3. Let me remind you, tangent is opposite over adjacent. So cotangent is adjacent over opposite. That means the adjacent side to the angle must be negative 3 and the opposite side must be 1. Well, we need to find this distance here that I'll call r. You know r squared is equal to 1 squared plus negative 3 squared, or 10. So r is equal to root 10. R is always positive. So this is root 10. So we'll go ahead and replace r with root 10. So now we know what our cosine is. Cosine of x over 2 I don't know, but I can figure it out because it's the square root. I'll leave off the plus this time. 1 plus, and the cosine of x, this second quadrant angle, is going to be a negative 3 over root 10, adjacent over hypotenuse. And that's all over 2. And that 2's underneath the radical, right? I don't know if it's been clear that whole time, but it is underneath the radical. Well, we got to simplify this stuff. So a lot of our work is arithmetic in nature in this section, which is good because these skills are necessary skills to go forward. So what would you do? Whoops, I forgot I still had my eraser. So let me make that look better as a square root. So what would you do? Well, maybe you'd multiply everybody by root 10 to get rid of the root 10. So if I hit everybody by a root 10, I'll come in here and put that in red. So I'll hit this guy by root 10, this guy by root 10, this guy by root 10, and clear that guy out. What do I get? Let me switch back to this. I get the square root of root 10 minus 3, because those root 10's cancel, all over 2 root 10. So the only reason I'm not done is because I got this root 10 in the bottom. Well, there's actually more reasons than that, so let's keep going. So let's multiply top and bottom by root 10 again. And what do we get? And there's always more than one way to do this. Root 10 times root 10 is 10, minus 3 root 10, all over 20. Well, they're not going to be happy with that either. That won't be an answer reflected in the back of the book. And I'm just going to double check to make sure it shouldn't be. And that's because we have a 20 under there. Well, here's the problem. Let me just make sure you see it. It's the same problem as we had before. We got a root under there. Remember what this is. This is root 10 minus 3 root 10 all over 2 root 5. So the big problem is the root 5. So we'll come up here and we're going to multiply top and bottom by root 5. Now that's a big root 5. So that 5 is underneath the radical and therefore can hit numbers underneath the radical. So we're going to get a 50 minus 15 root 10 all over root 5 times root 5 is 5 times 2 is 10. And that's what they have. 50 minus 15 root 10 all over 10. So hopefully that was clear. When we had, let me just put out this guy really quickly that we did up top, because that's where I get the most confusing looks. People say, well, the square root shouldn't hit it. These square roots, let me highlight them. These square roots right here, these ones that I'm trying to highlight here in yellow, I thought it would do a little bit better there. Make it, oops, and make it a little bit thicker. That's what I was hoping to find. those square roots right there are at the same level. So this 5 is at the same level as the 10 and at the same level as the 3. And so it's going to come and make a 50 and a 15. Just wanted to highlight that in case it was confusing. This is the answer. That guy right there. So what is it? It's a lot of arithmetic work. The trig was done in 2 steps. 1 step, 2 steps. The rest is arithmetic, right? Algebra skills, I guess, potentially could be considered that. And so there's other ways that they ask. Now notice this one's just 2 questions later, but the question has kind of shifted a little bit. Oh yeah, it's not too much. It's the cotangent of theta over 2. I don't remember what cotangent of theta over 2's formula is, but we can go and look. Cotangent of theta over 2. Let's go find it. Let's come back right up here, make note of what it looks like. Cotangent of theta over 2 is not here. So what are we going to do? Well, what could we do? As we look at this guy, we know that cotangent of theta over 2 is 1 minus is 1 over tangent of theta over of theta over 2. So we could handle it like that. 1 minus tangent of theta over 2. And so we're going to have to basically flip what we have at some point. And so what is that tangent? So this is one that's pretty involved. So I don't know which one would be the best one. Now notice there's 3. I'm not sure that this is the best one to flip. This one looks pretty good to flip. Maybe this very next one right here. And what's nice about these two is they don't require a sign choice. It's been made for us. Let's take that one. The one that says sine A over 1 plus cosine A. Okay, so we know that tangent of theta over 2 is equal to sine theta over 1 plus cosine theta. Well, that means cotangent of theta over 2 would be equal to 1 plus cosine theta all over sine theta. It would flip those two, because that's all that would happen is a flipping of those guys. So then the question is, well, what is sine theta? Well, we could create a triangle again and find those values. There's other ways to do it. We absolutely could use identities as well if you want to do something like that. Theta is a second quadrant angle. How do I know that? Because they tell me it's between 0 and 180 degrees. I'm sorry, it's between 90 and 180 degrees. That's how I know it's in quadrant 2. And its tangent, which is opposite over adjacent, is root 5 over 2. And so we need to know what this r is for both cosine and sine. So r squared is equal to root 5 squared plus negative 2 squared. Or r squared is equal to 5 plus 4. Or r squared is equal to 9. So r is equal to 3. And so what do we have? We have that the cosine is adjacent over hypotenuse, cosine of theta. And the sine of theta is opposite over hypotenuse. So root 3 over 3. So sine of theta is root 3 over 3. Oh, opposite's not root 3, apologize. What's the opposite? The opposite is root 5. Sorry, I misread that. Root 5 over 3. So cosine theta is negative root 2 over 3. Sine theta is root 5 over 3. And we're ready to go. So what do we have? We have 1 plus negative 2/3. Makes sense that cosine would be negative. Sine's going to be positive, root 5 over 3. and then we just kind of clean it up from there. So I'm just hesitating just to make sure that we're okay with what came out there. Tangent is opposite over adjacent, so the negative 2 is the adjacent side, and quadrant 2, so I think we're good. Just double checking there. And so what do we have left to do? And just clean it up, right? Just use our arithmetic skills and clean that guy up. So personally, I would clear all the fractions by multiplying everything by 3. And so I would get out of that 3 minus 2 all over root 5. So 3 minus 2 all over root 5, or negative 1 over root 5. Or not negative 1, sorry. Not negative 1. 1 over root 5. And so our answer is square root of 5 over 5 as our guy there for number 26. So and just double check that that's what they got for 26. It is. And so root 5 over 5, are we shocked to see that it's positive? No. If you half a second quadrant angle, theta over 2 is going to be in the first quadrant. In that first quadrant, everybody's positive. Okay, so we're asked to find sine x now, given cosine of 2x is 2/3. And x is in quadrant 3, right? So we definitely know x is in quadrant 3. And so sine x. Sine x, well, do you agree that sine x is the sine of 2x divided by x? Oh, not by x. 2x divided by 2. I hope you don't agree with that. 2x divided by 2. Now, why would I do that? I'm just trying to use the information that I'm given. I haven't been given the cosine of x, and I'm not being asked the sine of 2x. And so the nice part about trig is they're expecting us to be free thinkers, to go through this and think well about the situation that we're in. Now, why would this be advantageous? Because you know that the half angle formula for sine, the sine of a over 2, is plus or minus the square root of 1 minus the cosine of the doubled angle, all divided by 2. And the nice part is we know the cosine of 2x. It's just going to be a number plug, and I don't even have to draw a triangle off to the side. But I should decide whether I'm positive or negative. Now remember, sine x is what we want. So it's this that we want to know whether it's this piece, sine x, whether we want to know whether it's positive or negative. They're telling us about x. X is in the third quadrant. In the third quadrant, sine's negative. So we're choosing the negative. And now it's 1 minus, and cosine of 2x is a nice 2/3. So this is a beautiful one. We won't have to deal with rationalizing the denominator. I would personally hit everybody by 3 and get, well, I apologize, we will have to rationalize the denominator. I didn't mean that, but we won't have a square root within a square root. So we're going to multiply everything by 3, and I'm going to get 3 minus 2 all over 6, which is equal to negative the square root of 1 over 6, which is equal to negative 1 over root 6, which is equal to negative root 6 over 6, as this answer for number 30 for the sine of x. And that's what they have, negative root 6 over 6. So that's the arithmetic that's involved here. So they're very good problems because they're not just slam dunkers, right? You got to think through them. So let me break this video here into 2 segments. So we'll come back and we'll do a second portion of this 5.6 section.